Okay, so welcome. This is question 1 for Edexcel's M1 June 2003 past paper. Okay, so what we're given in this question is a plank, and it's supported by A and C. Okay, and we're told that it's got a length of 4 meters. A distance between points A and C is 3 meters. So therefore, I've just drawn on a couple of extra points. Now, we are also told that the mass, the rod is a uniform plank, is a uniform one, which means a mass acts in the centre, so halfway along, obviously. And we're told the mass is 40 kilograms. Now, obviously, we need to attach a force to that, or the force in terms of the weight. So, obviously, therefore, we need to times it by 9.8, and you can work out whatever that is. But I'll do it later on, okay? We're also told that the support at A and the support at C, so SA and SC, are exactly the same, okay? I've labelled them RN, okay? That's just the reaction force at that point, okay? So, what we have to do here is calculate SA and SC, okay? But we're also told, something I haven't drawn on here, a man of mass 80 kilograms stands on a plank which remains in equilibrium. Okay? Now, this is just where I've drawn, it just happens to have been drawn here. Now, for working out part A, this has absolutely no effect on where you put him. Now, it obviously affects the second part of the question, but ideally you want to put him on the left hand side, somewhere over here, okay, because the mass, we need to balance it out, okay, so really, we need to put the man over, it doesn't matter, somewhere over here, okay, so it doesn't matter exactly where you draw him because we don't know the distance, okay, so just draw this blob thing. We know it's 80 kilograms, okay, so just draw 80 kilograms. Obviously we need to times it by 9.8 to get his weight. Okay, but his distance to A is X meters, okay? Now we don't need to put on his distance to everything. The reason I'm putting distance to A is because on part 2 or B, it asks us to work out the distance to A. So I've just labelled it as X meters, okay? So realistically, he could be past the weight really, and I'd still write X meters to A. But as I said, it's just a figure that I've come up with for his distance. Okay, so what we need to do is find the value of R. Now, that'd be quite difficult. If we just use our standard hypothesis of finding moments in sort of this kind of form, what we'd normally do is SA times the distance between them equal to the moments to SC, which, as I said, there's probably a method behind that, but that's a simple way we'd work it out. Now, we can't work it out because we don't know this X meters, obviously, and it's asked us to find it in part B for another 4 marks, so obviously we don't need to work it out just yet. There's obviously another way, and by looks it's only worth 2 marks, so it's obviously a more obvious way of working out what Rn is, okay? So let's, as I said, what we'd normally concentrate on is, well, the clockwise moments equal the anti-clockwise moments. And that you could take that if you're at A or C, okay? But we're not going to be at A or C, we're just taking account of it generally. Okay, now, it is, as I said, it's a lot more logical if you just think, well, what's pulling it up is equal to what's pulling it down. Now, I do admit that these forces will end up going, in a clockwise or an anti-clockwise moment, depending on which point you stood at on the plank, okay? But really, these forces are sort of pulling it up, and the force of the weight of the board and the weight of the man are pulling it down, okay? They may be going in a clockwise moment if we grasp it at A, okay? But, as I said, it's just the way you look at it, okay? So, really, what we're saying here is the force is pulling it up, the equal force is pulling it down. Now, I wouldn't write that in your exam, because it doesn't look too, doesn't look very intelligent of you. The way you would write it, okay, so this is part A. Now, Rn plus Rn. Now, you could just write 2Rn, okay, so the reaction force at A and reaction force at C, so Rn plus Rn, is equal to the weight of the man, okay, so 80 kilograms times 9.8, plus the weight of the board, which is 40 kilograms times 9.8, therefore it's 2Rn, if you haven't wrote that already, is equal to 80 kilograms times 9.8. Now you could just combine that to say, well, it's 120 kilograms times 9.8, because they're both times by the same figure, okay? Right, and then what you would do there is just divide all of that by 2 both sides. So Rn is equal to 120 times 9.8 over 2, okay, or 60 kilograms times 9.8, okay, so that's the reaction force, Rn, and that is equal to 588 newtons. Okay, so that's the reaction force at either of them, okay, they're both the same. Now, what we need to do at pi is work out the distance from the man at A. Okay, so therefore to do that we have to work out the moments at A. Okay, and when we're talking about the moments at A, we talk about the clockwise moments equal to being the anti-clockwise moments. And if we're stood at A, okay, so if we're there, where we're looking down this way, this force is going to be going round that way. And the weight of the ball is also going to be going clockwise. So these two forces are clockwise if we're stood at A. Okay? And then the anti-clockwise, this one is just going to, obviously it's not going to keep going up and up and up and up. It's going to follow the circular motion. Okay? So it's going to go anti-clockwise, therefore. Now what we normally do at this point is, okay, well, say we didn't know what SC was, but we know it's equal to the reaction force, which we've just worked out. But what you would naturally want to do is say SC times the distance between them to A, okay, which is obviously 3 metres. So SC times 3 metres is equal to the distance from the first force to A, because it's a perpendicular distance, obviously. And we know the distance is 2 metres, okay. So it's 2 metres times the 40 kilograms times 9.8, okay, so the weight. Could probably combine that into one sum. Plus, and then we do the weight of the man, so 80 times 9.8, and then we times that by the distance. But we don't know the distance, so we're just going to label it as times x metres. Okay. So it looks like we've got two unknowns here, but as I said, we know this SC is this SC here, which is equal to the reaction force, which is what I've just worked out in part A, okay, which is 588 newtons. Now, as I said, that's rounded. You want to use a pure figure you get for that. Okay, so you sub that in here. So 588 newtons times 3 metres, okay, and that's equal to 2 metres times 40 kilograms times 9.8 plus 80 times 9.8 times x metres. Now I've wrote x metres, I've just come up with x, okay, but the actual x value meant to represent the distance from the man to A. This blob is meant to be the man, okay, represents quite a lot of people I know, but anyway, right, so what we need to do now is just simplify these numbers, okay? So the 588 times 3 comes to 1764 or 1764 newton meters, okay? Don't forget the newton meters. And then so 2 meters times 40 kilograms times 9.8 obviously comes to 700 and sorry, let me just double check. So I'm just double checking something, I do apologise. I do apologise, sorry, worked that out and it should just pause the video. Okay, so if you work them two out, you I do apologise, I'm a lot slacker than this. Obviously, because we've got 80 times 9.8 plus 80 times 9.8 times x, okay? Yeah, so you work out 2 times 40 times 9.8, so I do apologise for my brain just went funny for a second. So that's 784 newton meters. plus 80 times 9.8. Okay, 80 times 9.8, which is also 784. But this is times by x, okay? So 784 newtons times x meters. Okay? So that's what was getting me confused, because I thought, well, it's not. It's 784 here plus 784 times x, okay? So what we're going to do here is take away 784 from both sides. So that's 1764. Take 784, okay, which gets us 980 newton meters. So really, I'm just simplifying it down. And that is equal to 784 newton meters times x. Divide both sides by 784, okay? Divide both sides by 784, which gets you x to be 1.25 meters. Okay, so hopefully that made some kind of sense. I do apologise, I just couldn't see the difference between adding that and having that times by x. That was my main problem. As long as you can see the logic, I can't, that's alright. You're going to pass your exam. Hopefully not. Well, hopefully that's just screwed up. But anyway, so that's question 1 really. It's just a simple moments question, even though I couldn't calculate simple maths. Anyway, so thanks for watching. Hopefully it's been of some help, and we'll see you in question 2. Hopefully. If, whatever. I'll say hopefully, I don't know what about sometimes.